Welcome to Algebra 2, Semester 1, Unit 5, Section 5.2. This is the very first section of this unit. It's a fairly short unit, as you'll notice. We only have 3 videos if all the taping goes well, and then we have 3 book assignments. We do have a couple in-class projects that we'll do, some activities, and then you'll be taking your test on this one. Hopefully you learn a lot about polynomial functions with this. The title of this is, gosh, I couldn't even tell you. Graphing polynomial functions for this section. Probably just polynomial functions, their behaviors. Okay, very first thing that we want to look at here, again, up at the top of this page 2, you'll see the vocabulary, and it's all matched up. If you just put A, B, C, D, E, F, G, and so on down through this and match them up. I am finding the students who are studying the vocab are helping their test grades considerably in that matching where they don't lose points. If you are saying you can never learn vocabulary, that is a lie. I would really encourage you not to come in alignment with that, but instead continue to explore what helps your brain to remember and work through doing flashcards, doing audio recordings, whatever it might be. It does take investment, and it does take time. Both of those happen to be things that oftentimes you won't want to give to something, and then you just say that you can't do it. So push past that, lean into it, and let's get somewhere with that. So the first thing here is just classifying and naming our polynomials. I'll give you an example of this fx equals a sub 0. That would be an example, would be f of x equals just a constant value, 5. There is no variable in that, so we do call it a constant because it doesn't have an opportunity to vary. It has the value 5, and it will always have that value 5. It's to the 0th degree, because the way we get the degree is by taking the variable of the leading coefficient and adding the exponents that are on the variable. Since there's no variable, there's no exponent, so the degree is 0, always. Okay, the next one does have a variable to the first power. We would term that as a linear function because that x is to the first power. We don't always write first power on it. Usually you will see that it just says x because we do not need to write the 1 there showing that it's to the first power. Okay, so that is the first degree. Now the next one, when we get to the second power, we have a quadratic. If it contains all the terms possible, then it will have a term to the first degree and a constant. It doesn't have to have all of those terms in order to be a quadratic. All it needs is this leading coefficient. With a variable to the second degree. That's what makes it a quadratic. And then you could even just skip down and have a constant attached to it, or you could just have it by itself. It's still a quadratic. The degree is 2. Going on down the table, you can see the pattern. The next one is cubic. It is to the 3rd degree. And a good example would be x cubed and then minus 2x squared plus x minus 5. Okay, you can have all the terms, or you could have just the x cubed or anything up to the x cubed. The next degree would be 4th degree. We call that quartic. And the highest degree will be 4. You could just simply have f of x equals x to the 4th. Okay, you could have any number of terms that have a lower degree than that with it as well. So in the next little section, we're going to explain whether or not the expression given is a polynomial or not. So go ahead and look at those. This does appear to be a polynomial. We don't have any x's or any variables in the exponent or any variables in the denominator. So it appears to be a fourth degree. Or we could call it a quartic. With a leading coefficient. Now the leading coefficient is the coefficient off of the highest degree. And if this didn't have the highest degree first, I'd rewrite it. But the leading coefficient there seems to be 1. Okay. Next up, this is not a polynomial. Can you see why? What looks different to you in this one? It's not polynomial. Hopefully you said it's because of this x to the negative first. We know from our exponent unit that that should be simplified into a positive exponent, which would make it 3 over x to the first, and that puts our variable in the denominator. That is not going to happen in a polynomial expression. Next page. This next polynomial that we're given appears to not be in order, so we would first simplify it. The reason I say it appears not to be in order is we've got an exponent of 2 here and an exponent of 1 there. So we rewrite that. Pi x squared plus 7x minus radical 3. The proper order for a polynomial, standard order, would be the highest degree first, and then for each term after that to just come in descending order. So since this one has a degree of 1, even though we don't write it, and this one has no variable, so that's a 0 degree, we just put them in the order of 2, 1, 0. Okay, this is a second degree, or a quadratic. And the leading coefficient is pi. Okay. Next one. Why would I say this one is not a polynomial? If you said it's this term right here that's causing the problem, you're exactly correct. It's not a polynomial because every term in it does not have a variable base and a whole number exponent. So that's what we need to have. We can't have a variable exponent. So not a polynomial. Okay. Now we're going to evaluate polynomials for a given x value. Ignore the L down below, just leave it for a minute. I'll show you a shortcut in a minute how you can evaluate these. But for right now, if it says x equals 3, that means we just plug 3 in for the x values. So on this first one we would have 2 times 3 to the 4th minus 5 times 3 cubed minus 4 times 3 plus 8. Okay. Next step, we would take 2 times 3 to the 4th power would be 81 minus 5, 3 to the 3rd power would be 27 minus 4 times 3 is 12 plus 8. 2 times 81 is 162 minus 5 times 27 is 135 minus 12, negative 12 and a positive 8 would be negative 4. Now if we put these together, 162 minus 135 is 27 minus 4 is 23. Okay. Now, if you're having trouble doing some of those, have plenty of scratch paper available. If you have not passed all your standardized tests, I highly encourage you, do not use a calculator. In order to pass these tests, you need to have very sharp basic math skills and be able to do this kind of math. If you're having trouble on basic multiplication or division, feel free to come see me or look up other YouTube videos on how to do that. Here we plug in -2. Go ahead and pause the video and do that and then come back on and I'll have the answer here. -2 to the 4th plus 2 times -2 cubed plus 3 times -2 squared minus 7. -2 to the 4th would be 16 plus -2 cubed would be -8 times 2 is -16 plus -2 squared is 4 times 3 is 12 minus 7. 16 and 16 wipe out because they're positive and negative, so we have 12 minus 7 equals 5. Okay. I want you to go ahead and do these two on your own. Pause the video, and when you come back on, I will have it written here. Okay. I purposely didn't give you the answer to the last one. I'm going to be able to check and see if you actually worked that out on your own. Okay. I want to show you a shortcut. This is called synthetic substitution. And what you do here is you really just look at the coefficients and you can get your answer that way. So instead of substituting this in and actually working it out, this is a form of division. We write what we're wanting to evaluate, that x equals 3, right here by the division box, upside down division box, and then bring all of your coefficients in descending order down. So I say this is a 4th degree. My suggestion is up above the problem write x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0th. Okay? Now we'll bring their coefficients down below those exponential expressions. So x to the 4th, the coefficient was 2. X to the 3rd, it's -5. X to the 1st is -4. We do not have an x squared, so we put a 0 there. Then we have an 8, positive 8 for our constant. Now watch how fast we can do this. We bring the 2 straight down, and we multiply 3 times 2, and we get 6. Now, in all of these, we're just adding them. So 6 plus a -5 is 1. Now we take 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus -4 is positive 5. 5 times 3, 3 times 5 is 15. 15 plus 8 is 23. Your very last term there was your answer up there. So I'm basically showing you how you can evaluate without having to plug in and do all that other math. It's just a nice shortcut. Let's do it again on this one. First we start with our highest degree, x to the 4th, right? X to the 4th, x to the 3rd, x squared, x to the first, and x to the 0th. Then we take what we're evaluating, that -2, we put it out in front of our synthetic box, our division box. And now we bring down their coefficients. X to the 4th has a coefficient of 1, so we bring a 1 down here. X to the 3rd has a coefficient of 2, bring a 2. X squared has a coefficient of 3. X to the 1st, we don't have an x to the 1st up here, so we write a 0. And then our constant is -7. Okay. First step, do you remember what it is? We drop this down, and now we start multiplying. -2 times 1 is -2. Add these together, we get 0. 0 times -2 is 0. 3 plus 0 is 3. 3 times -2 is -6. 0 plus -6 is -6. -6 times -2 is +12. 12 plus -7 is +5. There we go. Same answer. Okay. One more time. Our highest degree here is x cubed, so we'll write x cubed, x squared, x to the 1st, and x to the 0. Again, please pause the video. I know that I go fairly fast on these because I know that you have a pause button. Do not try to do these without pausing. We're evaluating for x equals 4, so we put a 4 out here. Our coefficients for these terms are 1, -5, 6, and 1. We didn't have any zeros in there. Okay, drop the first one down. 1 times 4 is 4. 4 plus a -5 is -1. -1 times 4 is -4. 6 plus a -4 is 2. 2 times 4 is 8. 1 plus 8 is 9. The nice part about Algebra 2 is we get far enough along for you to see some really neat shortcuts. Okay, last one, we didn't get an answer for this one on the videotape, so right now you can check the answer that you did get. We take the 2, plug it in here. Our highest degree is cubed, so we go x cubed, x squared, x to the 1st, and x to the 0th. That's your constant, because x to the 0 is equal to 1, which is a constant. Our coefficient for x cubed is 5. Coefficient for x squared is 3. Coefficient for x is -1. Coefficient for our constant, not really a coefficient, it's just our constant. Okay, so now we drop down the first one, that's 5. 5 times 2 is 10. 3 plus 10 is 13. 13 times 2 is 26. 26 plus -1 is 25. 25 times 2 is 50. And 50 plus 7 is 57. So check your answer and see if that's what you got. Okay. Now we'll go to page 3. On page 3, you see up at the top, we're talking about end behavior. End behavior is on a graph. We're really talking about how the graph ends as it approaches infinity. To the right, infinity, positive infinity, and to the left, negative infinity. So that's what behavior means. End behavior is the behavior of a graph as it approaches positive or negative infinity. Okay? the behavior can be determined. They're similar, there's patterns to this, and the similarities lie in the degree and the sign of the leading coefficient. Okay, you've all seen polynomial functions in this class when we have a degree that's even. Remember when we were doing transformations, we had x to the second, and we've done a few with x to the fourth. And so as we come out here, as x approaches, oh, I've got this one first. As x approaches negative infinity, so as x is going this way, what's happening to your y values as you go up this graph? Do you see how the y is going higher and higher? So as x approaches negative infinity, y, or the f of x, approaches positive infinity. As x approaches positive infinity, y again approaches positive infinity. Okay, now without me even filling this in, I would think that you'd be able to from your transformations lab. You know that that's a positive leading coefficient, because when I take you over to this next one, I'm sorry that the lettering fell off the graph, as well as the graph. That was a computer error when I printed it. But see how the graph's going this direction? If you want, you can put it back up here on the graph. But that's our general direction. Now we'll just use these words over here. This time, even though it's even, we have a negative leading coefficient. In other words, we have a negative x squared, or in all honesty, this would be like x to the fourth or sixth, because the x squared doesn't have that tangent that comes down to the x-axis in between. But as x approaches negative infinity, going this way, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches negative infinity. So you see that an even polynomial will have this w or u effect where both directions, both end behaviors are going in the same direction. Now, if the degree is odd, and you saw this with our cubic transformations, and the leading coefficient is positive, then we get that muscle man pose, like what I explained in class, where you have the one arm up in the air flexing the muscle and the other arm down behind you. As the x approaches negative infinity going this way, y is approaching negative infinity. And as x approaches positive infinity going up here, y is approaching positive infinity. Okay? If we turn that around and we transform it by putting a negative leading coefficient, again, you saw this with your transformation lab that you did in class, then all of a sudden we see the graph actually reflect over the x-axis, and we get the end behavior where as x approaches negative infinity, y is approaching positive infinity. And as x approaches positive infinity, y is approaching negative infinity. So become aware that that is a pattern that we see in all graphing. Anytime the degree is odd, those are the end behaviors. Anytime the degree is even, those are the end behaviors. You need to become familiar with that. Now, on the next page, I have you go ahead and graph some polynomial functions. Mainly, I want you to think about the end behavior. If we look here, we have got a negative, and it's the the cube root or odd root. And so we know that as x approaches negative infinity, y is going to be coming up this way. And as x approaches positive infinity, y is going to be going down that way. On the next graph, we see that it's even and it's positive, so we know that it's going to be coming off the graph on both sides going up. Okay? So now we come over, we can plug in values to get that -3 value. We plug that in. You could do it by synthetic substitution. -1, +1, 3, and -3. We plug in a -3, we bring that -1 down. -3 times -1 would be +3, 3 plus 1 is 4. 4 times -3 is -12. -12 and 3 is -9. -9 and -3 is +27. +27 and -3 is +24. So we know that 24 is our first value. Okay, next one. Let's plug in -2. We bring down the -1. -1 times -2 is +2. We have a +1 up there. 1 and 2 is 3. 3 times -2 is -6. I'm just pulling down these coefficients as I go. 3 plus -6 is -3. -3 times -2 is +6. 6 and -3 is +3. Okay. Our coefficients again from the equation up here is -1, 1, 3, -3. Okay, for -1, we bring down the -1 from there. -1 times -1 is 1. It makes 2. 2 times -1 is -2. That makes 1. 1 times -1 is -1. -1 and -3 is -4. So we have -4 on that one. Now when we plug in 0, it will wipe out all of our variable terms, and we just end up with a -3. Okay. When we plug in 1, 1 cubed would be -1. 1 squared is +1, so those two wipe out. 3 times 1 is 3, minus 3 is 0. Go ahead and do these last two on a piece of scratch paper. Pause the video. Now we take these points and we actually plot them as points. -324 will go off the graph. We'll skip that one. We do know that as it's -3, it is way up here, so that does follow our end behavior. We have -2, 3, so at -2, come up to 1, 2, 3. At -1, we have -4. -1, 1, 2, 3, 4. At 0, we have -3. At 1, we have 0. At 2, we have -1. And at 3, we have -12, which is off the graph. So we can plot that end behavior, and now just connect the points in between, just a rough sketch. Something like that. Sorry, I didn't see that you were off the grid there. Okay, next one. Again, we have our end behavior graph down here. It's coming up on both sides where it should be. So now we can go ahead and divide using our coefficients. So we have 1, -1, -4, and 4. Oh, we're missing. If we list our terms in descending order, we have x to the 4th, x to the 3rd, x squared, we're missing an x to the first, so we need a 0 there. And then our x to the 0th is 4. Okay, real important that you catch that when you're writing those down. So go ahead and do our synthetic substitution. We have -3. Bring down the 1. 1 times -3 is -3. -3 and -1 is -4. -3 times -4 is +12. That makes 8. 8 times -3 is -24. -24 and 0 is -24. -24 times 3 is +72. +72 and 4 is +76. So we definitely have this int behavior over here on the negatives coming up, if that's a +76. Okay, some more synthetic division. 1, put our 2 here. I'm just bringing down our coefficients from the last problem. Okay, 1 times -2 is -2. -2 and -1 is -3. -3 times -2 is +6. +6 and -4 is 2. 2 times -2 is -4. -4 times -2 is +8. 8 and 4 is 12. -1, we can probably plug that one in without too much effort. -1 cubed would be +1, because an even exponent cancels those negatives out, so that's +1. Then we have -1 cubed would be negative, but we also have a negative there, so that becomes +1. -1 squared is a +1, times -4 is -4, plus 4. So 1 plus 1 is 2, minus 4 is -2, plus 4 is +2. If we plug 0 in, it will cancel everything out but our constant, which is 4. If we plug 1 in, we'll still have 1 there. We would have a -1 for this term. We'll still have a -4 there, because 1 times 1 is 1, times -4 is -4, plus 4. So we have 1 minus 1 is 0, -4 plus 4 is 0. Okay, down to our next numbers. Bring down our coefficients. It was 1, -1, -4, 0, and 4. We have a 2 over here. 2 times 1 is 2. 2 plus -1 is +1. 2 times 1 is 2. 2 and -4 is -2. -2 times 2 is -4. -4 and 0 is -4. 2 times -4 is -8. -8 and 4 is -4. Oops, I'm sorry. Yeah, -4. Okay, so that's our value for when we have 2. Our last one, a 3 there. Bring down our coefficients again. 1, -1, -4, 0, and 4. Again, we get those from these numbers in front of the terms up here. Because we don't have an x to the first value, that's why we have to put the 0 in there. Now, we want to evaluate for when it's 3. Bring down the 1. 1 times 3 is 3. 3 plus -1 is 2. 2 times 3 is 6. 6 and -4 is 2. 3 times 2 is 6. 3 times 6 is 18. 18 plus 4 is 22. So now when they go off the graph, just agree with your end behavior. This one starts up at 76, so we know it's way up here. -2 is 12, we can't graph that either. -1 is 2, we can graph that. 0 is 4, 1 is 0, 2 is -4, and 3 is 22. So we know that the end behavior is going up like that. We also know that this end behavior is going up like that. Now we just connect in between. Something like that. Okay? This is your assignment when you come to class, page 341, number 3 through 50. If you happen to be at home, then you could go onto ClassZone.com and you could do section 5.2 with the e-workbook and copy down or print out the problems as you do them online. There is an online tutorial, so they will be telling you if you're correct or not. Have a nice night. We'll catch you tomorrow in class.